Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. We are moving past the era of individual AI models, the chatbot, the image generator, the classifier. I am proposing a blueprint for the next phase, a unified cognitive architecture. I call this the Omni-Layer Cognitive Architecture, or OLCA. OLCA isn't a single model, it is a deliberate synthesis of four of the most powerful, yet fundamentally different, AI paradigms existing today. We combine the intuitive perception of VLGEPA, the imaginative power of generative world models, the structural specialization of the society of mind, and the reasoning capabilities of agentic LLMs. My goal is to create a system that doesn't just process data, but perceives, imagines, organizes, and plans in a way mimicking biological cognition. Why do we need this complex merger? Because current state-of-the-art models are brilliant, but brittle. They are isolated islands of capability. VLGPA gives us incredible abstract intuition but cannot do math or logic. Generative world models can dream up photorealistic futures but often forget basic physics over time. Agentic LLMs can write complex plans but are fundamentally disembodied brains in jars, struggling to deeply understand the physical reality they are planning for. And the pure society of mind approach, without a strong central reasoner, descends into bureaucratic chaos. To achieve general capability, we must bridge these islands. We need a system that can intuitively perceive, explicitly simulate, and logically reason, all at once. Here is the proposed architecture, the OLCA cognitive stack. We organize the four paradigms not side by side, but in a hierarchy of abstraction. At the bottom, layer 1, we have the perceptual foundation powered by VLGPA. It handles the messy reality of sensory input, converting pixels and sounds into compact, abstract representations. It provides fast, intuitive thinking. In the middle, layer 2, is the imagination engine. This is where generative world models live. When the system is unsure, it uses this layer as a physics simulator, a sandbox to test actions before taking them in the real world. At the top, layer 3, is the executive. This is the realm of slow thinking, where an agentic LLM orchestrates a society of mind. It sets goals, interprets the simulations from layer 2, and makes the final decisions based on the grounding from layer 1. Let's look at the foundation. Layer 1 is our VLGPA implementation. In a complex real-world environment, raw sensory data is overwhelming and noisy. An agent doesn't need to know the precise pixel value of a raindrop. It needs to know it is raining and the road is slippery. VLGPA is perfect here because it doesn't try to reconstruct the world pixel by pixel. It learns to predict representations of the world. It filters out the noise and compresses massive multimodal streams into a stable, manageable abstract state vector. This vector is the ground truth that the rest of the system operates on. It also provides immediate, subconscious predictions, like intuitively knowing a ball will continue falling, without needing heavy computation. Layer 2 is where the architecture gains the ability to plan in complex physical environments. This is the generative world model layer. Think of models like Sora or Genie, but highly conditioned. When the executive layer, layer 3, is considering a dangerous or uncertain action, like a robot handling fragile glassware, it doesn't just guess. It sends the current abstract state from layer 1 down to layer 2 and says, simulate what happens if I push this glass. Layer 2 then generates a high-fidelity video simulation of that future. Crucially, this layer does work in pixels, because sometimes the details matter. Physics, collisions, and precise spatial relationships need to be rendered to be evaluated. It provides the system with a vivid imagination of consequences. Finally, at the top, sits the executive layer. This is where the architecture solves complex, multi-step problems. It is not just one giant model, it is a society of mind orchestrated by an agentic LLM. The agentic LLM is the conductor. It holds the main goal. But it knows it isn't an expert at everything. When it needs to analyze the detailed simulations passed up from layer 2, it doesn't just look at them itself. It deploys specialized agents from the society of mind. It might ask a vision specialist agent to measure the gap in the simulation. It might ask a safety critic agent to review the simulated consequence for violations. The LLM synthesizes the outputs of these specialists to make a final, reasoned decision. This is System 2, thinking realized architecturally. To make this concrete, imagine a robot tasked with cleaning spilled coffee near expensive electronics. First, Layer 1's VLGPA perceives the scene, instantly creating an abstract representation that flags the proximity of liquid to electronics. Layer 3, the executive LLM, realizes the danger. A simple wipe command might cause a splash. It needs to verify this intuition. It asks Layer 2 to simulate an aggressive wipe. Layer 2 generates a video showing the coffee splashing onto the electronics. Back in Layer 3, a specialized safety agent analyzes that simulation and immediately flags it as a failure state. The executive LLM discards that plan and formulates a new one, dabs slowly. This plan is deemed safe, and only then is the physical action taken. The entire process happens before the robot moves a muscle. The Omni-Layer cognitive architecture suggests that the path to AGI isn't just about scaling up a single transformer to trillions of parameters. It's about architectural synergy. By combining these 4 paradigms, we solve their individual weaknesses. We ground the LLM's reasoning in perceptual reality. We use generative models for safety instead of just content creation. And we use the society of mind to make the system modular and understandable. AGI will not be a monolith. It will be a symphony of specialized parts working in concert. I am now happy to take any questions in comments. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.